This video presents our online metagenomics binning workflow service for non-specialists where users can develop pipelines to bin sequences, visualize bins, refine bins and evaluate produced bins. But, what is metagenomics binning? Let's look at a real-world example. Let's say we have a set of books and we shred them into small pieces. In metagenomics, books can be thought of as metagenomics sample, and shredded papers can be thought of as pieces of DNA which are also known as reads, which generated through a process called sequencing. So, how does the binning comes into the picture? According to our example, let's say we need to match and bind these pieces of paper to produce the books back. Similarly in metagenomics, we try to group the reads we gained from the previous process to produce the genome back again. This process is called metagenomic binning. Now that you have a basic idea about metagenomics binning, let's take a look at the importance of the project. We provide improved performance for metagenomics binning workflows by using parallelization approaches. And also, even biologists and bioinformaticians with the least programming experience can do their analysis processes through this system. They do not have to worry about installing and maintaining the tools and other dependencies since we provide them as one online service. Now let's take a look at the architecture of the system. The application front-end consists of views, controllers, and services. The services communicate with the back-end cloud server instance. The results obtained after executing a workflow are stored in a back-end database to be retrieved later. Let's take a quick look at the overall workflow of the system. The platform includes various types of binning tools for taxonomy-free and taxonomy binning. Binning results can be further improved using Bin Refiner module. Final output bins can be evaluated using Check'em. Resulted plots can be visualized. Let's see how concrete workflow turns into physical executable tasks. At first, all the tasks wait in a queue. The steps that are ready to execute are sent to the step executor. Step executor is responsible for executing steps of the workflow accordingly. Wrappers are implemented for each tool that manages their execution. To improve the performance and reduce execution times, we have introduced 3 levels of parallelism. The first level focuses on parallelism inside a single task and it is harnessed by the integration of tools and services which support GPU acceleration. GPU-accelerated cloud platforms such as Amazon EC2 instances enable the incorporation of GPU-accelerated tools into our system. The second level of parallelism occurs among multiple tasks. Here, multiple branches are generated by splitting the main thread and the branches begin to execute tasks concurrently. Third level of parallelism is achieved by allowing the scheduler to distribute the traffic evenly to the processing cores and executing each workflow independently in an asynchronous manner. Now, let's see how we can execute a simple metagenomics workflow using our system.
This is the website of EasyBin with various tools and a canvas to formulate workflows. Let's pick a tool. First, necessary files should be uploaded to the server.
Now select the input files from the previously uploaded files. Let's pick another binning tool, a refining tool and an evaluation tool. Again, select the input files from the server and set the parameters for each tool. Then connect the tools appropriately to create a workflow. Execute the workflow. Here, we can see the real-time status of the tools along with the workflow details. Once a tool is completed, the status is updated as completed as you can see here for the concat tool. The workflow is still running, not all the steps are completed. Some tools are in running or in incomplete status. Now, we can see the remaining tools have also completed the execution. And here we can see the overall workflow execution time is updated. Here, there is an option to visualize the evaluated results. We can download the results of each tool. Here there is another option to access the results of previously executed workflows using their workflow ID. We can insert the workflow ID here and get the results of the workflow. Thanks for watching.